Okay, Salihuddin ada. Assalamualaikum Saleh, Assalamualaikum semua. Good afternoon kat sini. Saya, I'm not working from home as well, same as you guys. Okay. Mas Fadila ada.
Ada doktor.
Thank you for coming in, Mas. Mas Fitri Jaafar ada. Ada, terima kasih. Tio Weizan ada.
Ada doktor.
Terima kasih. Farhana. Ada.
Ada.
Atira Haize. Okay. Nampak Atila? Atila ada tak? Nampak tak Atila? Nampak. Fatin Atira.
Ada doktor.
Ui, kuat dia. Okay, good job. Mula-mula sekali masuk. Nurul Izzah Aziz. Izzah Aziz ada? Izzah. Terima kasih. Siti Nur Hadijah Mahad ada?
Ada doktor.
Okay, terima kasih. Zaidawati.
Ada doktor.
Terima kasih. Nurul Nadia. Mana Nadia? Nama Nadia.
Ada.
Mana nama you tak nampak? Ada. Fakihah Abdul Halim.
Ada doktor.
Terima kasih. Lepas tu Nurul Izzati bukan. Muhammad Hafizuddin. Ada. Siti Nur Samiha Sakina.
Ada.
Thank you. Nur Zulaika.
Ada.
Okay. Siapa ni? Nazira.
Ada doktor.
Terima kasih. Dilona. Jarang dapat dengar suara Dilona. Hai.
Ada.
Dan Aini nombor 2 tadi masuk.
Saya doktor.
Terima kasih. Okay. So first and foremost, no, there's another one. Era Syamimi group ni kan ke bukan? Itu saya.
Era bukan grup ni doktor.
Sorry. Yang group ni Anis Hawani kan?
Ya saya.
Aduh, saya selalu confused. Alright. Okay. Thank you for all that coming in. So I wish you congratulations because you have done you punya midterm semalam. Saya belum check lagi honestly. Okay. Nanti apa-apa saya ambil lah. Alright, so next week is your midterm holiday kan? Okay, so today kita akan look into the topic of Alkane and Alkyne. We will recap whatever that we have discussed last week, okay? And then this week kita akan continue with the remaining, and then today we will complete hopefully everything. With my other groups, we managed to complete from Alkane until Alkyne, including the 4 mechanisms. Okay, today for the 2 hours, so that when we come back from the midterm holiday, we will start on Alkene halide. Okay, so kita terus saja. I think I can recap sendiri. Okay, where were we? Okay, so this is us share screen. So kita terus saja. Is there any question yang you tertanya-tanya dan sebagainya? Kalau tak ada, we can continue. So basically we have done Alkane last week. Okay, we did discuss about the properties, how to make Alkane. You know, we talk about the naming. And in fact, this is something that I tested you last night also about the naming for Alkane. Okay, so we are up until the reactions of Alkane. So we did discuss about this. One thing to note about when we talk about synthesis and reactions, we cannot discuss Alkane. I nak discuss Alkane reaction dengan synthesis Alkane je. Okay, without doubt, especially when we go into the topic of Alkane, you will also look into other functional groups. For example, reactions of alkene that making alcohol is also a synthesis of alcohol. Nanti bila kita sampai kepada tajuk tu, you will see. In fact, when we synthesize alkene, we can synthesize them from alkene and alkyne. Okay, if we use alkyne, we need 2 moles of hydrogen. Okay, but if you use alkene, only 1 mole of hydrogen needed. See, bila kita bercakap tentang menghasilkan alkene, we are already talking about the reactions of alkene, reactions of alkyne. Okay, now, so sekejap. All right, now, okay, now we can also synthesize alkane from the reduction of alkyl halide. Okay, we have discussed about this now. Bila reduction of alkyl halide, meaning that when we come into the topic of alkyl halide next week, we will also see these reactions. Do you see that? Kita belajar dalam tajuk alkane. At the same time, we are also already learn about alkyl halide. Okay? So, but an alkane only undergoes several reactions, and the most important ones is the halogenation reaction. This is a very simple reaction that we can actually do in our lab. In fact, okay, which one we will be putting in the dark, for example, dalam cupboard, and another one we will expose it to sunlight. So basically, this halogenation reaction is the only one mechanism involving radical. Okay, the other mechanism that you will learn today does not include radical. Okay, so what do we mean by radical? Radical means that you know that electron always comes in pair. Electrons always come dalam pasangan. There's always 2 electrons, but radical is single electron, 1 electron. Okay, and it needs such a powerful force for the electrons to break, and such powerful force can come from the photon of the light. Okay, so in this case we have 3 steps of synthesis. Okay, one is what we call as initiation, where we are forming the radical. Second step is propagation, more or less is the combining step between a radical and the compound that we wanted. And the last one, termination, is when there's no more radical. Okay? First step, initiation. We will use the photon to pisahkan, separate our electrons. Okay, and we will observe the radical electrons. And next one, we will propagate the chlorine atom radical with methane. Okay, and you will observe the methane radical. This propagation will continue to combining this metal radical with another radical from chlorine, and you will form chloromethane. And at the end of the day, you will get this termination step. Basically, we have observed the termination step already, which is chloromethane. Okay, so itu saja mekanisme yang berlaku. Now, we are moving into the topic of alkene. So for this topic, there are a lot in your course, SKO3023, the alkene functional group is the one with the most reactions. The one with the most reactions, okay? So, firstly, we will look into the IUPAC nomenclature. Basically, they are the same ones, okay? They are the same ones. IUPAC nomenclature with the previous one, alkane, with the exception of changing your ANE to ENE. Okay, this is something that you have learned prior to coming to my class, probably in matriculation or your STPM or your diploma. Okay, so you will number the chain so that the double bond has the lowest possible number. In a ray, the double bond is assumed to be between carbon 1 and carbon 2. So these are examples. Now, for me, I prefer the new IUPAC. I prefer the new IUPAC. Why? Because the new IUPAC actually elaborated more and it details to me where is my double bond. So basically, if you see, for example, this example, you see, it tells me that this compound has 4 carbons because it's built. It also tells me that this compound has a carbon-carbon double bond. And that carbon-carbon double bond is located at carbon 4. Siapa? Ya, Amir, apa? Amir, can you speak louder?
Tak ada apa doktor, sorry.
Okay. So because of that, saya prefer the new IUPAC. However, if you are comfortable with the old IUPAC, you can proceed also with the old IUPAC. With the new IUPAC, it will be helpful when you have a higher functional group such as alcohol, okay, such as later you will learn about acid, for example. For example, you have double bond and OH present at the same time, and then it will be useful untuk guna the new IUPAC. Alright? So the rest you can read, and then with the nomenclature, you will assume that the double bond is between carbon 1 and carbon 2. If you see this example, if we go into the IUPAC of Alkane, it says that you will prioritize on the where is your substituent. However, remember, Alkene has a higher priority in comparison to Alkane. Therefore, your numbers will be on the double bond. Okay? And what then when we have multiple double bonds? Basically, it's very same like when you have multiple methyl, for example. What you do is you are going to sum them up. Kalau ada 2 methyl, dimethyl. Kalau ada 3 methyl, trimethyl. Like this one. We have C double bond C, we have a double bond, but we have di, meaning we have 2 double bond. And that 2 double bond is located at carbon 1 and carbon 3. You see, from a naming, you can, dissect information yang diberikan. And then, last kali you tengok, oh, dia ada 4 carbon. So when we have multiple double bonds, you have to firstly number the longest chain with the functional groups of double bond, number them up, and then you will spell out where is your bond and sum them up. Kalau ada hepta, meaning ada berapa? Hepta tri-in. See, this is better. Hepta meaning ada 7 carbon, tri-in ada 3, C double bond, C. Alright? Now, alkene can also exist as substituent. This is to simplify things. For example, you have methylene group, which is CH2 at the end, a terminal methylene group. And then you might also have a vinyl group. The comparison between the two, the difference is just with vinyl, we have 2 carbon, ethynyl group. Okay? We have looked into this. We have looked into cis trans. We also have looked into EZ. However, in the first part of our knowledge about cis trans and EZ, we only be able to determine adakah dia E, adakah dia Z, adakah dia cis, or adakah dia trans. We don't need you to nama penuh dia. Name it in a full. But when we learn about alkene, we have to include their complete naming. For example, we have 2 pentene. For example, we have pen-2-ene. So one is cis, one is trans. Essentially, why do we need to put their isomerism? Because we know geometrical isomer. They are the same but they are different. Okay? Sama lah juga dengan EZ. Maksudnya now, barulah kita memaknakan. Now we actually define our EZ. Now we are defining our cis trans. Sebab sebenarnya macam like the one that I asked you dalam midterm test kan, saya minta you tulis E ke Z ke. It doesn't actually, in organic chemistry, there's no such thing as E or Z compound. We have to know their full name. Okay? Now, example, here we have 1 bromo, 1 chloro, propene. Just so you know, the numbering for carbon, for the 2 carbons such as ethene or 3 carbons such as propene, you don't need to do the numbering because, for example, for propene, you see, if you start it from the right hand side, it's still number 1. If you move the double bond to left hand side, the carbon will still be number 1. That's why you don't need to put number kalau propene. Tapi for carbon 4 carbons and above, you have to place the number because the differences in placing of double bond will result in different compound. Now, kalau kat sini E, macam mana E, you boleh go back to what we learned about this, and then one chloro and one bromo essentially because they belong to the same carbon 1. Okay. Now, commercial uses of ethylene. Now, ethylene is involved in so many reactions. Among them, that even you can make a polyethylene, make a plastic out of it. You can make acetic acid from ethylene. Okay. Now, this is something that we have seen, right? We have seen the reactions from alkene to alkane. Essentially, for organic chemistry, we don't need to look on the enthalpy. Okay. But physical properties of alkene, you boleh read through. So, and then Zaitsev rule. Okay, other student asked me on Wednesday, Doctor, what about this? Zaitsev rule. Are they the same? Because he said that he learned about it in matriculation. And I said it is the same. It's just the different in spelling. Maybe one is American, another is French, one is Russia, I don't know. But essentially, we are talking about the same thing. What is that really? Okay, Zaitsev and Zaitsev actually talk about where should we put our double bond. So basically, bila kita nak synthesize C double bond C, you have to know where you want to put your C double bond C. So in simple words, Zaitsev wants you to have the C double bond C with the most substituent. Kalau in my Dr. Yohanes punya word pula ialah double bond yang paling sedikit. So Zaitsev will prefer the C double bond C, it will prefer the carbon with less hydrogen. See? That's my simple words lah. Kalau you baca dia punya word yang panjang adalah dia prefer the most substituted carbon, most substituted alkene. But for me, paling simple nak tengok apabila dia ada kurang hydrogen. Okay, if you see this one has 2 hydrogen, right? This one has 1 hydrogen. Because of this one will become the major. See, it has less hydrogen. Okay? So basically in organic chemistry, basically untuk alkene lah, you will learn about 2 rules. The first one is Zaitsev. The second one is what we call as Markovnikov. So what's the difference? Okay, Zaitsev and Markovnikov. Zaitsev is when you want to make C double bond C. Zaitsev is when you want to make C double bond C. Markovnikov is the reactions of C double bond C. Got it? So Markovnikov, apabila C double bond C or the alkene react with something, then where you want to place the atom. Later we will see, I will explain further about Markovnikov rule. But so far, there's only 2 rules for alkene that you need to know. And the most important thing about that is that the application. Okay, you tak perlu tahu, okay, apakah definisinya? Apakah Markovnikov definisi? You don't need to. Yes, siapa tu? Alright, so that's the difference, Zaitsev and Markovnikov. Alright, so now this is something that I think I will browse through about this. We'll discuss further. We will discuss it further in the topic of alkyl halide. We will talk about the mechanism about SN1, SN2, E1, and E2. SN stands for substitution. E stands for elimination. Basically, you can read this through. Primary halide usually undergo SN2. Tertiary halide a mixture of SN1, E1, and E2. So, and they cannot undergo SN2. So you see, there's very big important words there about halide, meaning alkyl halide. That's why for me, this mechanism will be discussed in details when we reach the topic of alkyl halide. All right, now, what's the how to make alkene? Kita dah belajar dah how to make alkane, kan? Now we are learning about how to make alkene. There are several ways untuk make alkene. I would say you can focus on these two ones. Okay, the first one we will look into what we call as dehydrohalogenation of alkyl halide. You will use a strong base. The second one is the dehydration of alcohol. The second one ini, we will look into its mechanism. This one, we will look into the mechanism after this. Alright? So this one, I will show you dia punya example. The first one. Okay, dehydrogenation of alkyl halide. I don't think I have space. Okay, let me end this show first so that I can include a slide for example. Okay. So, for example, dehydrogenation of alkyl halide. Let me talk about, for example, I have this, okay, chlorine here, all right? And then I will react it with KOH, very strong potassium hydroxide. Actually, there are two options for me for the answer. Okay? Satu, the double bond will be there. Or the second one, my double bond could be there. Okay? This is where you have to use your Zaitsev. This is where you have to use your Zaitsev. Now, this one, how many hydrogen do we have? We have one hydrogen there, one hydrogen up here. This one hydrogen there, two hydrogen here. So if you remember, my Zaitsev said, Zaitsev rule set, it will prefer the product to be having less hydrogen. Therefore, this one is our major compound. Okay, that will follow the Zaitsev. Okay, so dalam ni you boleh cakap, okay, this is the major compound. Alright, so that's the use of it. Now, dehydration of alcohol is when we have OH, that means alcohol, making alkene. Tadi daripada alkyl halide menjadi alkene. Sekarang alkohol menjadi alkene. We usually use H2SO4, but we can also use H3PO4 phosphoric acid. Okay? So, and usually it will follow what we call as E1 mechanism. And this reaction will also obeys Zaitsev rule. Okay, the first one, what we do, step one, is the protonation of the hydroxyl group. Protonation of hydroxyl group. Sekejap eh. Okay. Firstly, what you do, this is where your knowledge about resonance will be helpful. Okay? Because you know which reaction or which electron pair that you can move. Okay, and then you are using and showing your arrows. Now the first one you see, we will use our OH, our oxygen at the OH with the two lone pair of electrons. Okay, that one will be pushed to our hydrogen at H2SO4. Basically, this one is our acid. Okay, H2SO4. And then we will left with the protonated oxygen. Okay, and now bonded to the hydrogen. And then from here, we will move our CO bond. Okay, we will transfer the electron pair from the CO bond to our oxygen, and we will left with protonated carbon. After that, I will show you later my summary or my kind of simpler way of doing this, all right? And then deprotonation to give the alkene, okay? So, this is an example of solved problem, but from here, let me show you my kind of, this one sebenarnya dia ada macam terbalik-terbalik sikit. This one. This one ni, you kena tengok balik, okay? Tapi let me draw, okay? Let me draw you my kind of mechanism. Kalau I boleh minta lukis mechanism, this is my way of doing things. Okay, very simply, we have third butyl. If you go into the previous one, we have third butyl alcohol. Okay, and then you will react with H2SO4. So I assume that H2SO4 has been dissociated into H plus and H2SO4. So I have H plus here. So I have lone pair of electron there. Firstly, I will react it to there. Okay. Then what I will observe is oxygen, hydrogen, hydrogen, positively charged oxygen. And then this one can be moved to there and I will get positively charged carbon here. And I know over here I have 3 hydrogens. This one can be moved there and then I have, what was that? Water? Do you have water or the OH, I think? We abstracted with the water. I'm true. Okay, I'm betul. And then what do I do is I got that from here and then I have to change my arrow color. Let's see. Okay. This one move to there. And then this one move to here. Okay. Sebenarnya ini dia punya byproduct dia adalah H2O. Okay. H2O. Tapi kalau you tak tulis byproduct pun okay. Right. And then this one bergerak ke sini and then we have this one over there and finally we have our double bond. Okay. Like that. Okay, actually this one punya byproduct is H3O plus. For me kalau tak tulis byproduct pun tak apa. You see, it's even simpler. Okay, ada apa-apa soalan dekat slide ni? Balik ni. You all dekat rumah try fahamkan This one I think you dah pernah tengok ni, I'm not sure lah. Okay, so that's how the mechanism work. Pushing your electron pairs. Okay, and then moving it from the electronegative atom to the more electropositive atom. Okay, so that's the second mechanism. So far you have learned about mechanism of radical reaction from alkene to make alkene halide. Second one, mechanism of reaction between alcohol and acid to make alkene. Okay. So this is a summary for reactions of alkene. Why do I include this slide? Because some student, when I was flipping slides, you see, when I talk about, okay, this is the hydrogenation, this is the halogenation. They cannot be able to summarize things up. When you summarize things up, you will see that all these functional groups are interrelated. 5 minutes, I've got 1 minute, I ambil air. So these functional groups are interrelated from one functional group to another. For example, from alkene, we can make alcohol. See? This one is alcohol. This one also is alcohol. But using a different reagent, we will get different product. From alkene also, we can make alkyl halide. So this vicinal dihalide is also a type of alkyl halide. From alkene, we can also make ether. See? Where is our ether? Ether is the very last topic for this course. Ether and epoxide. Maksudnya, bila kita belajar ether nanti, kita dah pernah tengok dah. Kalau saya cakap, okay, ether boleh disintesis daripada alkene. You know this already. From where? Daripada sini. For example, after alkyl halide, kita akan masuk kepada tajuk alkohol. Bila saya cakap, alkohol boleh disintesis daripada alkene melalui 3 cara ini. You know this already. Where? Here. You see? And then, for example, we will look first into alcohol, okay? How do you make this type of alcohol? See, this one is the one that include what we call as Markovnikov. Okay, this one is Markovnikov. Yang obey Markovnikov. So the one with Markovnikov is using H2OH plus as dia punya reagent. The one what we call as anti-Markovnikov is using boron, diboron hexahydride with peroxide, H2O2. Okay? Yang ini nampak tak hydroboration? Hydroboration is the one that will produce anti-Markovnikov. Later saya akan tunjuk. And then the one we call as hydration is the one that will follow Markovnikov. Ada dua reagent yang berbeza. Over here, you boleh guna osmium tetraoxide. You boleh juga guna what we call as KMNO4 coal. Sekejap macam mana saya nak tulis tak muat. Okay, I can also use tak muat. Use a different color pen so that you will see the difference. Purple. KMNO4. KMNO4 cool. Okay? Right. But KMNO4 can also be used elsewhere. Okay? KMNO4 can be used here. This is something that you haven't learned in this course. You will not learn in this course, but you will learn in the course of SKO3023. For 1813 student, it will be the course next to this course, okay? And you will learn about all the mechanism that's involved in it. But there you will learn what we call as the compounds containing carbonyl. Carbonyl is C double bond O. Okay, carbonyl is C double bond O. Basically, walaupun we are not going to learn about those functional groups, but because one of the reactions for alkene is what we call as cleavage. Okay, oxidative cleavage, okay, of alkene using two different reagents will give you two types of products. Okay, if we use KMNO4, so from C double bond C, if we use KMNO4, but this one you will use hot or concentrated, for example, okay. And then the product will either be ketone and aldehyde or ketone and or aldehyde. Okay, you will get this. Look back into apakah ketone, apakah aldehyde. Essentially, ketone is C double bond O in the middle with diapit oleh alkyl. And aldehyde is C double bond O with hydrogen. Okay, and then, but if we use ozonolysis, ozone maybe use dimethyl sulfide as dia punya reagent, we will always get acid or ketone, depends on our compound. Okay, so there are two ways of using potassium permanganate. If you use it cold, you will get diol. Okay, if you use it hot or concentrated or more acidic, you will get your acid, no, maksudnya you punya C double bond O will be cleaved, right? Now, in addition to that, you can also make ether from alkene and epoxide from alkene. Now, epoxide, you menggunakan this type of reagent. Okay, MCPBA, tak silap saya, stands for metachloroperoxybenzoic acid. So, daripada situ direct, terus apa yang dia buat adalah that salah satu daripada bond, the C double bond C, will be transformed into CO. Okay? Now, with the formation of alcohol tadi, we can also do a halohydrin type reactions, where one carbon will include whatever halide that you have, another will be include your OH. Okay? So, nama dia halohydrin. Okay? Another thing is using alkyl, the product will be alkyl halide. Cara nak buat dia adalah, for example, you boleh guna, this one you boleh guna apa-apa hydrohalide, okay? HBr, HCl dan sebagainya. This one pula, you kena guna apa-apa chlorine atom punya molekul. CCl4 tidak ada fungsi dalam tindak balas. Okay, dia adalah lebih, bukan, maksud I dia adalah sebagai reaction saja. Bila you buat mekanism pun dia tak involve. Okay, CCl4 tadi. Alright, so far, and then we have looked into this, right? Hydrogen and then platinum, for example. Okay, so more or less we have looked into all of this really here. Okay, selepas ini you will see them again. For example, banyak kali dah kita tengok, there are 3 times already that we learn about this. Okay, hydrogenation of C double bond C. Now we all have addition. This is where the one that will obey or disobey its Markovnikov rules. This one is the one that will involve Zaitsev rule. Okay. Type of addition, basically this one, this slide is explaining this particular side. But this slide is focusing on the reagent, okay? But this slide is focusing more about the type of reaction, the name of the reaction, okay? It can be hydration, halogenation, depends on the reagent that we'll use, okay? Now, when we talk about reaction in organic chemistry, you know, we can talk about reaction of A, producing, B, using reagent Z, for example. So, when we assess you, we can ask what is the product when A is reacting with Z, for example. Or, we can also ask you, find Z. Maksudnya kita just berikan the product, we give you the reactant. Or, we give you product and the reagent, and then you have to find the reactant ataupun dia punya starting material. So that's how it works. And usually, especially for 80 to 10 students, we or group C ada ramai juga 80, 16, but for SKO3023, we are not going to see a straightforward reaction. We will see a consecutive reactions yang bersambung-sambung macam tu. Okay? Just so you know that there will be no assessment on direct, okay, alkene ni bertindak balas dengan reagent ni, apakah hasil dia? No. It will be, for example, relate with alcohol, you know, those kind of things. So this is, we have seen this, addition of HX to alkene. We have step 1, protonation of double bond. Protonation step forms the most stable carbocation and then nucleophile, and then can be added. This is your third mechanism. First mechanism apa tadi? Radical. Second mechanism apa? Alkohol menjadi alkene. Third mechanism adalah menghasilkan alkyl halide. Menghasilkan forming of alkyl halide from alkene. Among all the 4 mechanisms that you will learn today, this one I would say the most simplest. Why? Because from here, dia terus pindahkan je. Yang double bond tu, dia terus pindahkan the pi electrons from C double bond to the hydrogen. And then we have the bond between hydrogen and bromine. You know already. Bromine adalah partial negative. Dia lebih cenderung untuk menerima. Okay, in fact, it's the electronegative atom. And after that, you will left with C+, maksudnya positively charged carbon. And over there, we will see what we call as carbocation. Carbocation ini satu steps yang involved dalam E1 mechanism. Okay. Now, sorry. I think about right. Okay. So, but carbocation saya akan emphasize untuk topik alkyl halide nanti. But essentially apa yang you perlu tahu ialah dia akan prefer, carbocation will prefer primary, not primary, tertiary, this one, okay? Rearrangement, okay, tertiary carbocation, okay? Tertiary carbocation is the preferred one. But, however, For me, if you want to discuss about convocation or mechanism, firstly, understood Markovnikov rule. Okay, sebab bagi saya bila you nak discuss mechanism, you don't work with, okay, mechanism dia apa, apakah hasilnya. For you, my suggestion is find out the product from the reaction first. Find out the product from the reaction first. Barulah you work out how does it form that way. Okay, find out the product first and then you work out its mechanism. Sebab over the years, some student dia boleh dapat confused. They will get confused sebab bila dia buat mechanism, tak dapat produk asal. No. So whatever the case is, find out the product yang obey Markovnikov atau for example obey Zaitsev dan sebagainya. Lepas tu you work out dia punya mechanism. Okay, from the positively charged carbon tadi, you have your negatively charged bromine, your nucleophile. Okay, that nucleophile will attack the electrophile, leaving a product that looks like that. You see, this one yang kita akan sebut Markovnikov. Apa Markovnikov ni cakap? Dia ada cakap panjang-panjang. There are the long definition of Markovnikov rule. But let me simplify things for you. Markovnikov said, okay, hydrogen will be added to carbon with more hydrogen. See, hydrogen will be added to carbon with more hydrogen. Okay, if you see here, between this, both of these, okay, for this type of reaction untuk yang ini, doesn't matter really because both are having the same material, same hydrogen. But if say, let me show you this one, okay, even this one, you can see that that hydrogen is ditambah kepada this one. Okay, this carbon has one hydrogen. This carbon doesn't have any hydrogen. That's why hydrogen is being added there. Okay, so we have this Markovnikov rule. So you can see for the examples, okay, this one is tindak balas of the tindak balas between alkene and hydrogen bromide, leaving your alkyl halide like that. Now, I think I'm going to give you an example. Okay, yang ni, alright, so I'll explain this first. So you see, in the solve problem here, the question is show how you would accomplish the following synthetic conversion. Convert 1 methyl cyclohexene to 1 bromo 1 methyl cyclohexene. If you've been given this type of question, first thing to note is find the references. Okay, find the references, find the difference. Okay, find the differences. So from here you can see that we are now changing the E and E to A and E, meaning we no longer have carbon-carbon double bond. From there also you noted that there's a 1 bromo being added as a substituent. So automatically you know it will react with hydrogen bromide. Okay. So more example here. Okay. For example, you have that alkene over there yang nak show ni, contohkan macam ni kan. So this carbon, why the hydrogen is being added here? Because that carbon has 1 hydrogen. Why is our hydrogen is being added to this carbon? Because this carbon have 2 hydrogen. Okay. Hydration of alkene. Perasan tak yang ini a reverse version of synthesis of alkene. Nampak tak tadi? Tadi kalau kita nak sintesis alkene, kita guna apa? H2SO4. Kata tadi you ada, for example, you have CH3CH3, CH2OH for example. Okay, if you want to make CH2 double bond CH2, you will use H2SO4, right? But if you are CH2 double bond, okay, I want to make CH3 CH2OH, okay, what do? I use H2OH plus. So for me in organic chemistry, it's better to have a summary. It's very good if you can compare. If you can compare, macam tadi, I compare between the two types of oxidative cleavage of C double bond C. I compare between the two K-aminophore, one is cleave, one is a diol. Okay? So this one also, if you can differentiate the reagent dan you faham, oh itu adalah tindak balas alkohol, satu lagi adalah synthesis alcohol. So hydration of alkene with H2OH plus will produce an alcohol following Markovnikov rule. Okay. So this is your fourth mechanism. Mechanism for hydration ialah you will protonate the double bond to form a carbocation. Okay, positive on the most substituted carbon. Itulah yang pasal carbocation tadi. And then nucleophilic attack of water to the positively charged carbon, leaving a oxygen positive charge. Di situ sebab you dah donate kan dia punya lone pair of electron. And after that, we will deprotonate the alcohol, leaving our the product that we want. Okay? Is there any question for now? Group C, is there any question for now? Kalau tak ada, we can go further. Okay, this one yang protonate. Ini yang saya kata most importantly understood where is your reaction will take place. Okay? And then this one is the one yang disobey and the Markovnikov rule. We call them anti-Markovnikov product. So essentially it is just the opposite of Markovnikov. Markovnikov said you add hydrogen to carbon with more hydrogen. So in this case, you will add hydrogen to carbon with less hydrogen. Is there any example? For example, I'll give you example here. Are you guys?
Yes, teacher.
Yes, doctor.
Senyap je semua tahulah petang-petang Jumaat.
Boleh tak nanti lepas doktor cakap slow-slow sikit? Maksud saya perlahan-perlahan sikit.
Itu yang saya nak dengar. Terima kasih lah. Sebab saya bercakap depan skrin. Jadi saya tak nampak muka korang berkerut ke. Muka you all macam lajunya ke kan. This is something that I want. Terima kasih Atira. Okay. Kat mana ya Atira? Should I re-explain previous one? Itulah saya bercakap dengan skrin ni saya tak dapat tengok muka. Saya pun tak tahu you all. Kat mana daripada reaction of alkene ke saya cakap mana laju-laju? Kat mana Atira?
Daripada mula sebenarnya.
Aduh, tak ada orang cakap apa-apa. Itulah. Terima kasih kerana respon. Terima kasih Atira. Kan, this is something that I want from you guys. Ada lain-lain kan tak? Ke semua tidur je pas.
Be okay je, doktor.
Saya explain daripada sini boleh? Re-explain. Sebab saya rasa, okay, terima kasih. Sebab saya rasa yang macam, I kena slow down. Slow down. Okay, sebab macam IUPAC naming, property alkane, synthesis and reaction of alkane, saya rasa macam dah okay. And then the naming for alkene, saya rasa pun not that bad. Okay, tetapi untuk reaction of alkene, perhaps this is among the first time ataupun yang you kena recap balik. Okay, so itulah untuk alkene ni sebenarnya kita boleh bahagikan kepada beberapa balas yang dia boleh lalui. Okay. Okay, you nak balas mula-mula I would say C double bond C to C OH. Okay. So the way to do this, there are several ways. Katalah saya guna, let me show you an example. Okay. If I use H2OH plus, okay, I'll get Markovnikov product. Markovnikov product dia kata, sekejap lagi saya tunjuk perbezaan. Satu lagi saya guna B2H6, H2O2, H2O maybe. Alright, ni kena pendekkan sikit. Okay, satu lagi I pakai KMNO4 co-dilute neutral. Okay, mana-mana. Okay, from here I'll get, okay, and then this product pula. Okay, so let me show you the differences. So untuk H2OH plus is the one that will follow Markovnikov. Okay, kalau Markovnikov kata hidrogen akan ditambah kepada karbon yang banyak hidrogen. Kalau you tengok kat sini, this carbon, this particular carbon for example, have no hydrogen. This one ada satu hydrogen, betul? So our hydrogen will be added here. And we will add OH there. Okay, so untuk diboron hexahydride, dia adalah opposite. Okay, dia adalah anti-Markovnikov, so I will put my OH there, my hydrogen here. Okay, now KMNO4 co atau dilute macam saya cakap tadi, or neutral, is where you will form your diol. See, all of that are making OHs. Okay, next one, maybe we will talk about the cleavage, or let me talk about the reactions of bromine, for example, CCl4 and bromine HBr. So these particular ones will not follow any rule because dia adalah addition of two bromide atom, bromo atom, bromine atom. This one is the one that will follow Markovnikov sebab, again, if you see this one is addition of hydrogen to carbon with more hydrogen, and then this one of course will be another atom there. Okay, so I think we will proceed. Yang ini yang the one that I'll show you, Markovnikov and Zaitsev. And then this one is the name of the reactions. Yang ini the type of assessment that we can give you.
Doktor,
Yeah.
dah
Yeah,
tengok yang tadi tu.
mana?
Yang
Yang
doktor
ni
tulis, yang sebelah dia.
Yang ni ke?
Okey, dah.
Okay.
Doktor nak tanya, so basically kita tengok region dia, kalau ada H dia ikut Markovnikov, kalau tak ada H dia tak ikut Markovnikov ke?
Yeah, betul. Betul. Kalau macam hydroxide, kan macam hydroxide menjadi OH, tapi basically sebab you ada H2O. So H2O dia adalah H dengan OH. See, H2O dia adalah H and then OH. That's why satu kita tambah kepada carbon yang banyak hidrogen, satu lagi kita tambah yang kurang hidrogen. Okay?
Kalau yang B2H6 tu?
B2H6 tu dia anti-Markovnikov. Dia punya mekanisme dia, I think quite complicated on this one. Tapi apa yang you kena faham daripada situ, kalau you dapat this reagent, hasilnya mesti opposite Markovnikov rule yang ada. Boleh?
Region dia fix ke doktor?
Region macam mana?
Region dia ni nanti kena bagi dekat soalan ke guna region ni ke macam mana? Ataupun dia bagi produk sedia, lepas tu kita...
Okay, macam ni. Saya bagi contoh lain sekejap Sebab ini nampak macam straightforward kan, saya bagi contoh lain. Okay, katalah saya ada this type of compound. Barulah aktif, barulah saya tak mengantuk, you pun tak mengantuk, saya dengar je. Nanti saya baca berita kan. Okay. Say I have double bond there, double bond there. Okay, itulah macam ni kan. Okay, so I react dengan B2H6 H2O2 H2O for example. Okay, di sini H2O2 kat bawah. Okay, so apakah hasil dia? So kat sini you kena tengok di manakah ada banyak hidrogen. Di sini ada hidrogen. Di sini this carbon no hydrogen, right? Therefore, remember for reaction, apa yang kita asal, okay, the carbon that is the beginning of the reaction must be the same number of carbon at the end of the product, okay? Sebab kecuali the number is being added, meaning you are adding carbon, then the number will be different. For example, here we begin with 7 carbons. So you punya produk mesti ada 7 carbon juga. So kalau you tengok macam ni, now, of course the double bond here is no longer there, betul tak? Sebab kita tambah. Kalau you tambah OH kat situ, tapi double bond ada, maksudnya carbon you dah pegang 5 tangan, which is wrong, okay? Which is wrong. So for example here, the initial hydrogen that is already there is this hydrogen, okay? So this is CH3. So no hydrogen at the carbon there. Therefore, then we will add hydrogen here, we will add OH there. Nazira, does this answer your question? I'm not sure. What do you mean by region is fixed? Okay, this is okay?
Okay. Thank you.
Sama, maksudnya you kena tengok soalan tu lah. You kena tengok rupa dia macam mana kan. You know, it can be many type of, katalah you ada very straight chain like that, and then you have something like that, you know, whatever, the very strange looking ke apa. But the most important thing is you tambah kepada carbon yang kurang hydrogen. So maksud I ialah hydrogen ditambah kepada carbon yang banyak hydrogen. Another one will be added to the carbon with less hydrogen. Okay. So dekat sini tadi siapa yang nak tengok? Nadia ke? Ada soalan kat sini Nadia ke? Siapa yang tadi nak tengok ni soal?
Yang bawah tu dia follow Markovnikov rule kan?
Yes.
Okay.
This one dia follow Markovnikov. Very good. Yep. So kiranya overall dalam you punya Alkene punya discussion ada 2 tindak balas yang follow Markovnikov. Satu ialah halogenation, satu lagi ialah hydration ataupun hydration. Okay? So saya nak buat comparison satu lagi. For example, I have this structure. Okay, let me draw. Okay. Ini kiranya saya dah rangkumkan yang belakang-belakang tu So katalah I have this structure. Okay. So I use 2 type of oxidative cleavage. Ni saya comparekan terus. One, I use ozonolysis with the presence of dimethyl sulfide. Another, I'll use K-4 hot, for example. Okay. For ozonolysis, what you do is you are actually cleave your double bond C there. So kejap lagi saya nak tunjuk macam mana you nak buat, tetapi saya tunjuk teruslah So semua orang bila you buat ni tolong ambil pensel. You kena buat ni guna pensel. Okay. So what you do is untuk double bond tu you kena lukiskan panjang. Tapi saya sebab saya duduk dekat komputer so I cannot lukis panjang. So I buat macam ni. Alright, sekejap lagi saya tunjuk example. You yang tengah-tengah tu you lukis straight je. Straight je. Semua orang lukis Ni I dapat macam ni, I dapat macam ni. Okay, this one also the same. Okay. Now, apa yang you boleh buat daripada sini easily? You all guna pencil kan? So, siapa boleh respon pada saya? You all guna pencil?
Ya, doktor.
Okay. So, from there, tengah-tengah tu tolong padamkan. Padamkan yang di tengah. Padamkan tengah. Semua orang dah padam? Lepas tu, you akan tambah oksigen.
Doktor.
Ya.
Oh, okey, nampak dah. Terima kasih.
Lepas tu, yang ini sebenarnya ada hidrogen kan kat sini. Okay, dia ada dah, yang ni dia jadi satu alkohol, satu aldehyde. Yang ini kita panggil aldehyde. Ni functional group je, bukan nama dia tau. Ini ni ketone. Okay, tapi this one sebab dia guna KMNO4. Potassium permanganate ini adalah strong oxidizing reagent. Macam tadi you nampak kan, daripada alkene jadi alkohol. So over here dia akan jadi OH. Kalau kat sini, you habis soalan you tinggal macam ni. Dan you kata, doktor sengit-sengit macam ni betul ke? Boleh ke macam ni? Boleh, tak ada masalah. Because you are actually letting me know that you know what is the answer. Regardless of dia punya shape. But if you want to make it civilized, yang saya tak bagi extra mark pun, kalau you nak jadikan dia civilized, you bolehlah lukis secara macam ni. Dapatlah. Macam ni kan? Tambah double bond O. Kita dapat 2 propanon. Okay? Untuk yang ini. Macam tu. Untuk yang ni kita dapat CH3. COOH. Itu aja. Acetic acid plus sama juga 2 propanon. You see? That's the difference. Using a different reagent, you boleh dapat different product. Okay? So far kita dah tengok beberapa reagent yang berbeza menghasilkan produk-produk yang macam ini dalam kumpulan functional group yang sama. Okay, alkohol. Yang ini dalam kumpulan alkyl halide. Tetapi satu ialah dihalide, satu ialah monohalide. Yang ini pula adalah the same reaction. The cleavage of double bond O. Okay, and then you will get your different functional group. Okay? Any questions so far? Okay, kita proceed sekejap lagi juga saya akan tunjuk. Alang-alang tunjuk ni saya sukalah terus tunjuk-tunjuk the difference. Okay, kalau kita ada, let me show you if we have alkene, for example, like this, okay, for example macam ni, okay. Kalau you react dengan KMNO4 kan, you will get OH, betul? So far that we have agreed upon this, right? But if I use propine, triple bond, using the same reagent, okay, I will not get that, but I will get this. You see, dioxo then. Okay, so amazing. Using the same reagent, different starting material, get different product. Okay, tak apalah. Saya cerita tentang alkyne terus. Nanti dalam tajuk alkyne, kita pun tengok lagi sekali. Sebenarnya, reaction of alkyne have a lot of similarities with reactions of alkene. It's just the difference kat for example, nanti kita akan tengok. Yang you hanya faham, for me, it's easily like this. Faham je reaction of alkene dulu. After that, you can understand the reaction of alkyne. Any question here? Or here? Okay, semua orang answer me?
Okay, doktor.
Okay. Alamak. Okay. We will go into... Okay. Air jatuh. Okay, we will go into... Ni dah tengok. Okay, untuk 4 mekanism tu clearkan radikal, mekanism daripada OH jadi C double bond C, mekanism dari C double bond C jadi OH tadi, mekanism dari C double bond C jadi alkyl halide. Yang itu saya rasa as much as I can explain here, you have the obligation to do your own self-study juga. And then perhaps see several exercises that you can find online, or even from this particular existing example pun boleh tengok. Okay, retry. Ini Markovnikov, nampak tak panjangnya lah explanation Markovnikov. Apa yang saya cakap kat you? Hidrogen ditambah kepada karbon yang banyak hidrogen. Sebenarnya apa yang dicakap ialah very specific lah, tapi for me we can simplify things, can't we? Right? Okay. So I've seen this, done that. Hydration, we look into the mechanism. Okay. The one with anti-Markovnikov, right? And then this one is addition of halogen. Okay. And then mechanism of halogen addition, ada nucleophile dan sebagainya. This one you will read further. Mechanism of halogen addition to alkene. Yang ni ada halogen ion, saya tak nak explain sangat. But this one is another good example of reaction between C double bond C and hydrogen bromide, where at the end of the day you get your Markovnikov product. See, bila you buat mechanism, you can get confused bila you dapat carbocation. Bila dapat carbocation, it's okay. Carbocation, SN1, SN2, E1 itu saya akan explain dalam alkyl halide nanti So sekarang ni the course that we are now, we are left with the topic of alkyl halide, alcohol, and ether, epoxide. Okay? Alright. So catalytic hydrogenation of alkene again. This is how many times already we have seen this? Fourth time. Okay. Syn hydroxylation of alkene. Okay. This one, nampak tak? Or Cadmium-4 basic. Okay. Or Cadmium-4 coal ataupun you guna osmium tetraoxide. Okay. Right. So permanganate dihydroxylate. Okay. Basically sama in this one. You guna Cadmium-4. Cadmium-4. Nampak? A co-dilute solution of Cadmium-4. Okay. Yang paling penting, kalau you guna Cadmium-4 tu, you kena state dia punya temperature. Cold, hot, dilute, concentrated. Because different condition will give you different product. Macam yang saya dah cakap tadi. Okay. So oxidative cleavage which is Cadmium-4. Now if the solution is warm or acidic or too concentrated, see, those are the words, the keywords that you kena focus. Kalau you fail to letak condition, your reaction akan fail overall. Okay. So these are some examples where, nampak tak this one dia cleave this one aja. Try buat, gunakan pencil. So draw and then guna pencil, erase tengah-tengah macam yang saya ajar pada you all. Dapat tak produk macam ni? Kan? Yang ni sebenarnya kalau saya very simple je. Kan? You bahagikan tengah-tengah dua ni je. Letak oksigen dapatlah hasil je. But always remember, because we are not talking about Cadmium-4 instead of ozonolysis, make sure if you get any aldehyde, you have to change it to alcohol, OH, not alcohol. So you will get final product as acid. Okay, this is the one yang I cakap tadi, ozonolysis, which will left you with aldehyde and ketone, or depends on whatever product that you have. Okay. So see that dia guna basic and cool actually. And then yeah. So this is the solve problem type. Okay. This example actually, instead of wanting to show you the products, but this one wants you to figure out what is the reactant, what is the starting material. They give you product, figure out what is the starting material. So daripada sini you boleh baca-baca, tapi if it was me, how do I do it? Okay, kalau saya, macam mana saya nak buat? Well, I know that I have like this. I have C double bond O, right? I have C double bond O there. No, wait. The drawing is a bit different. I need more wow. Okay. So, you know, all right. I have like that. Okay. Then I have like that. That- okay. I have macam ni. Good. And then I have methyl CH2 CH3. Okay. Macam yang saya pernah ajar you all, kalau saya, very easily, what do I do? Macam nak tahu dia punya starting material. Padam je lah oksigen ni. Tadi kita padam tengah kan? Padam oksigen. Sambungkan je. Sambungkan je. It does look a bit ridiculous because of the long bond there. But this is okay. We got the same product pun sama je dengan ni. Right? Kan? Kalau you nak civilize sikit, pendekkan je dia punya rupa. So it will be like this and then like that. So we have like that. Okay? Mana-mana. If you do like this point, doesn't mean that you're wrong. You see? Nampak tak? Faham tak? Kat sini, anybody can respond? You see, for me, this is the best way of learning ozonolysis. Kan? Senang je. You padamkan je tengah-tengah tu. Okay. Siapa jawab tu? Okay tak?
Okay, doktor.
Okay, doktor.
Nasihat Atira. Dengan seorang lagi, siapa yang cakap tadi? Tio ke?
Zat.
Okay. So gunakan macam ni lah. Senang untuk faham ozonolysis. But kalau tak, pelajar tak faham sangat. Okay. Now we have reached the topic of alkene. Okay, we have reached the topic of alkyne. So alkyne is the last one in our hydrocarbon punya chapter. Basically because alkyne now we have 3 bonds. So it's a triple bond type of compound. Okay, and the general formula is CnH2n minus 2. So there are 2 elements of unsaturation. So, you know, more or less it will be prone to more reactions. Nomenclature IUPAC, change A and E to Y and E. With this one actually is very interesting because I did figure out on Tuesday about when you have alkene and alkyne present in the same compound without other functional group present. Siapa yang you nak dulukan? Okay. So I think I'll show you the slide that I showed to my student in group B. Sekejap sebab kat sini saya tertinggal I think. So this one, where is it? So you can see my content is the same. Yeah, this one. This is a good, the good references that I found about when alkene and alkyne present in the same compound. Which one takes priority? So you know actually alkyne has a slightly higher priority than alkene. However, in terms of the numbering of alphabetical, why? Because it's Y and E, right? It has to be at the end. So you see the example here being given, pen 3 in 1 ion. Okay, so it's not pen 1 ion 3 in because Y and E is at the back. Okay, likewise over here, we have pen 1 in 4 ion. Okay, so basically a molecule that contains both double and triple bond is called alkene. The chain can be numbered starting with the end closest to the functional group that appear first. You see, functional group that appear first. For example, 6-ethyl, 3-methyl, non-4 in 1 ion. So you see here, yang ini very interesting because they use the new IUPAC. So this is why I prefer new IUPAC. New IUPAC, you boleh tell me, kat mana double bond, kat mana triple bond, what is the methyl, what is the substituent present. Okay, so itulah yang we discuss on with the other student, right? So example of nomenclature, basically the same with alkene. It's just that instead of E and E, you are now using Y and E. You know, like the existing IUPAC rule still applicable here. For example, find the longest chain, you know, and then name your substituent, how many substituent, put diorang punya, the numbering, things like that, still the same. So this one is basically common name. We call them common name. Acetylene is a common name. We call methyl acetylene, isobutyl, isopropyl acetylene, you know. So all this you can read that about alkyne. So ethyl usually in welding torches. So its other name is acetylene, right? So synthesis of acetylene from natural gas. You can see that there. Right, this is the one that we want. Synthesis of alkyne by elimination reactions of alkyl halide. You see, when we did synthesis of alkene, have we seen this or have we not? We have seen this also, where we react our alkyl halide with a strong base, the same one that you will use here, okay, the same one that we'll use here. Let me find an example. For example, this one. We have vicinal dihalide or germinal dihalide, depends. And then using your, for example, potassium hydroxide there. Okay, for example, potassium hydroxide there, you will get your alkyne. What's the difference between the previous one and this one? The previous one only have one hydrogen and one, so this one only have one hydrogen and one halogen. However, for alkyne to be formed, you must have two hydrogen and two halogen. Okay, then only using the same potassium hydroxide, you will get your alkyne. Now, this is again the summary for reactions of alkyne. If you see here, many of these reactions are similar to the one that we have seen in the topic of alkene. This one, have we seen this? Yes, we have. But what you need to do here is just add the moles of hydrogen. When you have 2 moles of hydrogen, 2 equivalents, you will get alkene. If you only have 1 equivalent, you ada alkene. Yang ini pun very interesting. Reduction from alkyne to alkene. Basically, nanti saya tunjuk example that, you know, using different type of catalysts, you will have different products, okay? And then we can also make germinal dihalides, okay, with HBr. For example, the same ones that we have seen before, but this one is, you know, added dalam, you know, previously we only add H and then Br. But this one you are adding Br, there's 2 Br there. Later kita tengok examples. And then we can also form tetrahalides. You can, you know, print this out and then have it side by side to the alkene. You see it's very similar. All right, then we can also make aldehyde ketones, okay, and then carbonyl via oxidative cleavage juga, sama, right? So this is an example here, very good example, where you have dibromopentane, 2,3-dibromopentane. Using potassium hydroxide, we get pentyne. Okay, so this KOH elimination tends to give the most stable, most highly substituted alkyne. More or less macam Zaitsev juga. Okay, dia akan bagi most highly substituted alkyne. This one, we have seen this again and again. It's just a different, make sure you have 2 moles of hydrogen. The hydrogenation with Lindlar catalyst. This type is what we call as Lindlar catalyst. It's a combination between quinoline and methanol. All right. So you will get a cis alkene. But if you use sodium ammonia, you will get a trans alkene. Let me show you an example. Okay, I'll use a different color. Right. For example, I have, you know, I have like this, for example. And then I have like that, like that, like that. Okay, too complicated. I'll use the simpler one. Okay, I have this, right? I have this compound. So, tak nak buat macam ni lah, I padam semua. I have like this. Alright, I have that. Okay. So I gonna 3 hydrogenation. If I use hydrogen palladium, for example, okay, 1 equivalent so that I'll get, even kalau I tak buat cis trans pun tak apa yang ni, katalah I get this one, I want to make it like this. Satu, dua, tiga, empat, lima. 1, 2, 3, 4, 5. Make sure what you have previously, what you have before is the same what you have after for number of carbon, because we are not adding any carbon. So we can do it like that. Even kalau I nak tukar my soalan ni, kan, tiba-tiba tukar soalan, semua orang marahlah kat saya sebab dia orang dah draw kan. Tak saja saya nak tunjuk. So I can show you something like this. Okay, but if I use hydrogen, but I use here lila catalyst, what do I have? Dia kata kalau use cis lila catalyst, I dapat cis. So bila cis, double bond begitu, okay, your hydrogen there, and then we have methyl. 1, 2, 3, 4, 5. Tapi kalau I use Na, sodium dan ammonia, I'll get a trans ones. Got it? So from a single compound using different reagent, I can get different products. Okay? So now, shall we proceed? So, ni okay semua orang? So additional mole of halogen, this one that I've told you earlier. You see, you relate this one with the one for, Atira, tak apa clear,
Tak dok, tekan.
Okay. Okay, so addition 1 mole of halogen, kat sini you boleh tengok. You compare this one with the reaction of alkene with bromine juga, where you have dibromo. Here we have a dibromo as well, but this one is 1 mole. 2 moles of halogen, you will get tetrabromo. Okay, so addition of HX juga sama. If 2 moles of HX are added, the product is the germinal dihalide. You see this one? This one is 1 moles of HBr. So hasilnya you bukan dapat alkane, you dapat alkene. Okay, these are halogenations of alkyne. How does it work? It more or less sama je dengan our halogenation of alkene tadi. Okay, but the differences yang ada alkane chloride ni. Okay, and then anti-Markovnikov addition, you see here, this one is for peroxy lah, peroxy. Usually bila ada 2 oksigen, peroxy, sama ada macam kita biasa guna H2O2 for example. Okay, there's many other peroxy that you can use. So from C double bond C dapat jadi C double bond. So from C triple bond C, pentyne dapat jadi pentene. So this one, kalau you don't put mixture E, Z and semua tu pun tak apa. Yang penting you tahu kat mana the H and the Br should be added. Which carbon? Hydration of alkyne. You see here, Markovnikov. Sama je. Sama. It will be the same with alkene. Okay, so these are the mechanism explained. So we also have oxidation of alkyne. Ini, if you see here, dilute, neutral, cold will give you diketone. Warm give you triple bond, cleave triple bond. Nanti kita tengok produk dia. And then ozonolysis also cleave triple bond. This one diketone ni sama dengan yang saya explain yang ni. When I compare the two. When I compare the two, this one. When I explain to you here. See? When I explain to you here. Inilah. Diketone menghasilkan dua ketone. Okay? So, right. See? See this one? It making, instead of having OH diol, it will just substitute both of them menjadi carbonyl. C double bond, O, right? And then if you use KMNO4, you will get both acid. Okay, both acid, right? And then ozonolysis produce carboxylic acid. So alkene give aldehyde and ketone. See, that's the difference. Kalau alkene tadi, you cleave alkene, you dapat aldehyde ketone. Alright, so yang this one, dia akan menghasilkan carboxylic acid. Okay, so that's it. That's it for alkane, alkene, and alkyne. Is there a question, you guys? You can ask me wherever.
Doktor,
Ya? Yeah? Siapa cakap?
mi Tio.
Ya, Tio.
Doktor ada tutorial tak untuk yang ni?
Actually, saya tak prepare tutorial. Do you want a tutorial? Let me think. I can try to find question, tapi macam mana? Sebab I don't want you to feel obliged untuk buat, because some student they want tutorial, some student don't. Can I give you a suggestion? You can go online and find some exercises for reactions of alkenes, something like this. Because if I give you tutorial, maybe some student, nanti you kata nak kena hantar kat mana ke apa kan. For me, what do you want? Maybe, Theo, can you go online and see if you can find some exercises online?
Yes, Doctor, no problem.
I actually do have a combined tutorials more or less that I used before, but you know, let me know if you want, then I'll try to find several questions, or I try to make my own questions for you to try on. Sebab untuk organic chemistry, one thing to realize is this: what I really want you to understand is the relation between several functional groups. Let me give you an example. For example, you know, I can draw a question like this. For example, let me think. For example, I have this question. Okay, I'll have for example, I have from that one. For example, I show you something like this, you know, and then, you know, for example, I give you something like this, right? What you have to, it's as ridiculous as it can be, but you have to figure out. Let me know what is your proposed structure A, what is your proposed structure B, and what is X, what is Y, what is Z, right? So daripada sini, this is kind of straightforward example, but this one yang kita nak tengok relation lah between several functional groups yang ada. You know, so from here you can figure out that this is alkene, right? Your functional group is, this is alkene. And how does this alkene look like? See, this one is C4, meaning we have 4. This one also 1, 2, 3, 4. This is also C4. That means we don't have additional carbon. Okay, untuk additional carbon juga nanti kita akan tengok contoh nanti dalam Grignard reagent. Okay, I don't think there's a lot of additional carbon yang you boleh tambah untuk tajuk yang you belajar untuk SKO3023. Tapi maksudnya the number of carbon don't change. So then you have to figure out what is A, what is B, and what is Z, right? So from here, you know what you can think from here. It is basically alkene to alcohol. But can you make a 3-step? A 2-step. This one is 3 kan? 3 step. 1, 2, 3 step. But can you make a 2-step? You can make a 2-step reaction daripada alkene jadikan alkene, for example. Tapi you know, alkene tak boleh jadi alkene. Sebab alkene dia hanya boleh jadi apa? Alkene hanya boleh jadi alkyl halide je. Itu je yang you belajar setakat ni. Betul tak? Alkene hanya boleh jadi alkene.
Sama dengan haloalkane ke?
Apa dia?
Alkyl halide.
Yes. So alkyl, yes. So usually the functional group is called alkyl halide. But in reality, because alkane has a higher functional group than alkane has a higher functional group than halide, therefore we call it as haloalkane. That even the naming will go bromoalkane, something like this. It's the same thing. Okay? Boleh? So alkane menjadi haloalkane atau alkyl halide sahaja yang boleh. So you can think that it could be perhaps something like this. And how do we make that? From bromine HMU. Remember? If you put bromine CCl4 underneath, then this is already a wrong answer. Because with alkane, we need the presence of photon. Remember, with the radical, we need light. Okay. Then from alkyl halide, what can you make? What do you think will be the intermediate to make alcohol? You can make what? Alkene, right? You can make alkene from there to here. You can make alkene. How do you make alkene from alkyl halide? You use potassium hydroxide. Now, from alkyl halide, we already figured out that it can be alkene from potassium hydroxide. What then is the potential Z? You know that this can be achieved by hydration of alkene. Then we get this one is Markovnikov product. Well, it doesn't matter because it's just direct butane, butanol. It doesn't have any substituent. So Markovnikov really don't play any role here. Okay, because both of these carbon with the C1C have hydrogen, one hydrogen. This is the thing that I really want my student to be able to understand and comprehend from this chapter. Instead of having, this reaction, from this reaction, what the product will be. This is the type that, you can understand, the relationship, things like this. Try to find something over online because you are at home, right? So, with the time that you have, try to find some sources online that can help you with the exercises. Okay. Yeah. So does this more or less answer whatever that you need to from me, Theo?
Yes, doctor.
Yeah.
So I can find by myself the exercise. If I encounter any problem, I PM doctor.
Of course you can. It's very helpful that even if you find something, for example, when we come up after the midterm holiday, we will discuss about alkyl halide, you see. But then, for example, during the midterm holiday, you did several exercises about alkene. And apparently, some of the question, that relate to alkyl halide you don't understand, of course you can ask me during the lecture of alkyl halide. It's very helpful that we can also share with other people. And in fact, if you ask me personally, usually I will also share with other students. Okay, tapi my preference is just sharing with everyone. Okay, but if you need to discuss about something, yes, you may text me. Okay, so is there any more questions?
Doktor
Ya, saya. Siapa cakap?
Farhana.
Ya, Farhana.
Contoh kalau soalan dia dalam bentuk condensed formula kan, kita boleh jawab dalam bentuk condensed formula juga atau skeletal?
If the question does not specify, dia tak specify, sukatilah. Mana-mana pun boleh. Kalau the question specified, macam contoh dalam midterm test kan, saya spesifik kata saya nak constitutional formula tu in a line angle or skeletal structure. Then you have to draw the corresponding structures. If the question tak cakap apa-apa pun, then you can use either one. In fact, kalau I memang suka skeletal structure. Easier for me to draw, especially dalam cam draw kan, bila nak I draw questions. Sekejap sekejap guys, hold on. Okay, so any more question you guys? Ya, siapa cakap?
Dijah.
Ya, Dijah.
Doktor, yang di hydrohalogenation of alkyl halide tu, reaction dia tu kan KOH. Dia KOH sahaja ataupun ada KOH in ethanol ataupun
you can write macam, sebab biasanya kalau contoh contohnya dia punya, kalau you tengok in the topic of alkene, synthesis of alkene daripada alkyl halide. Okay, kalau you tak letak, you can write ethanol and things like that, but essentially those are solvents. Kalau you letak KOH pun for me dah okay. It's not necessary kalau you nak letak ethanol, sebab ethanol is just solvent. So dia macam doesn't play much in the tindak balas sangat lah for me. Kalau I will still accept your punya apa benda? Argument tadi. The KOH suffice. Tak perlu letak ethanol. But essentially kalau you baca lebih banyak, potassium hydroxide dalam whatever solvent yang ada. Tapi this one suitable, dah cukup. Boleh ke Dija?
Boleh doktor. Thank you doktor.
Some things macam bromine tu, dia kena letak. Sebab kalau you tak, macam ni, kalau you letak ada beza tak? Contoh macam bromine. You letak H mu dengan you letak CCl4, ada beza. For example, KMnO4. If you put cold, you put hot, ada beza. Okay? For example, what else? Actually with H2SO4 pun there's two different temperature. You boleh tengok strong temperature dengan low temperature. Yang mana menghasilkan ether dan sebagainya. Jadi kita tengok dalam tajuk ether. Okay? So there are things here yang for me I sort of explain a lot kat sini. Tapi you can try to figure out lagi. Macam ni kan, this one doesn't actually tell KOH dalam apa, they just ubah the temperature. Let me see. Synthesis of ether boleh daripada alkene juga, but it will use, let me find that summary. The different temperature of H2SO4, really? Let me find that. Okay. They use H2SO4 juga. Nanti kita tengok dalam tajuk ether. Okay. So, is there anything more that you want to ask me? Ada lagi? So more or less saya ceritakan dia punya, yang penting kena faham reaction dengan tindak balas tu yang macam ni. Kalau saya, contoh nanti kita belajar tajuk alkohol kan, sebenarnya kita dah belajar pun macam mana nak sintesis alkohol macam tu. So maybe helpful untuk you all try buat your own mind map kan, try to figure out macam tu. Okay, anything else you guys?
Doktor,
Ya, Tio?
boleh tak kita orang macam tunjuk kat doktor untuk assignment? Macam artikel yang kita pilih tu suitable or not?
Oh, assignment. Boleh. Of course boleh. Ya, sebenarnya suitability tu sangat bergantung kepada resources. Some very good journals, so okay je. In fact, kalau journal tu peer reviewed pun boleh je. Tapi sometimes you find online, you find e-book for example. Atau katalog ke, of course you can show me, boleh. Boleh Tio, tunjuklah pada saya artikel tersebut. Dan boleh juga sebenarnya you can, because sometimes the article tu katalah dia bukan journal, tapi perlukan untuk you faham tentang the kandungan of the product. It's just a website link. You know, so kadang-kadang satu website link tu dia tak ada apa-apa dokumen yang attach, but the information are there. So okay. Sometimes you boleh juga kena tengok lah, sebab ada kadang-kadang ada blogger tau. Blogger yang tulis tentang satu benda. So with blog, saya selalu question about the genuineness of the writer and whether that writer has scientific background. Kalau so there are things kalau journal saya boleh terima je. Kalau dia commercial item macam dia punya pamphlet ke apa, of course. Tapi kalau dia blog, you have to see baliklah whether that's true. Kalau boleh, with my student, I encourage you all actually to do a reference for a journal. Sebab I was told that you guys have been taught about how to find scientific journals. Okay ke? Tapi sebab kita kan cerita tentang macam commercial stuff, right? So, of course you can, Tio. Yeah.
Okay, thank you, Doctor.
Sama. Anything else, you guys? So, you punya final assessment, yang home assessment tu, will be very different from your midterm, very different. Because kita tak akan tanya dah benda-benda dalam midterm tu. Okay? My focus is macam ni lah, this type of question. I'll give you reactions and then you have to figure out. Or I might give you the kind of like, show me the synthesis step to make whatever. At least 3 steps contohnya. And with this answer, show me the mechanism. Okay, that kind of for final assessment lah macam tu. Okay, nanti kita try tengok lah whether kita sempat buat exercises online ke kan. Okay, before. So saya imagine I have another 7 weeks. 8 weeks, sekarang baru week 6 kan. So ada 8 weeks, so kita ada topik-topik itu saya rasa saya boleh cater dengan cepat so that we can have time to do exercises. Okay? Any more from you guys? No? If there's no more, saya akan adjourn the class. Anyone? Class rep Amir, is there anything that you want to let me know ke apa ke? Amir, are you there?
Ya, saya.
Ada apa-apa nak tanya ke apa ke, tak ada?
Tak ada.
Okey je. Untuk you punya, apa yang tak settle lagi sekarang, lab report kan? 2 lagi eksperimen kan? Eksperimen 1 tu saya sempat record dekat dalam lab masa sebelum PKPB. So, siapa tu? Ya, Tira?
Doktor, laptop hang je.
Tak apa, okey je. So, saya try untuk compilekan benda tu, banyak kali dah saya try. Try jugalah dalam minggu yang you all cuti ni, so that lepas pada tu kita boleh tunjuk kat you guys. And then the last one, eksperimen terakhir tu, saya rasa saya kena ambil whatever yang ada available lah. Kecuali I can try to masuk lab and try to figure out macam mana nak buat. Okay? don't worry, we have time before 20 of December, which is your deadline for submission of group assignment and lab report. Okay, don't worry. Ini 3 je eksperimen. Okay, so kalau tak ada apa-apa, saya nak end this class and I hope that you have a good rest for your holiday. Next to and kat dalam ni ada orang yang celebrate Deepavali tak? I rasa tak ada kan? So kalau ada, saya cakap Deepavali Vartaka kepada semua and have a good rest for happy holiday. Take care everyone. Bye-bye.
Doktor,
Yeah.
Bye, Doktor.
Yes, Sada. Yes,
Doktor tak
Sada.
dengar suara saya kan?
Yeah. Hi, Sada. Thank you for submitting. I'm so happy.